Welcome everyone. In this lesson video, I'll be teaching you bearing and distances. This is one of the topics in mathematics where we usually represent the information in a diagram. So anytime you are given a question on bearing and distances, you are expected to make a sketch, represent the information in a diagram. On the board, I have a question. Two cyclists, A and B, left a town C at the same time. Cyclist A traveled for 5 kilometers on a bearing of 050 degrees, and cyclist B traveled for 15 kilometers on a bearing of 320 degrees. Illustrate this information in a diagram. Now, for you to draw this, you need to represent each point using the 4 cardinal points. There are 3 points mentioned, A, B, and C. And they said both cyclists A and B left a town C at the same time. So the first point we are going to represent is town C. We represent it using the 4 cardinal points, which is north, south, east, and west. Okay. Just to remind you, every movement we make in bearing, we take it from the north. We'll start the angular movement from the north. So every movement is a clockwise movement. When you are starting, the north is 0. When you get to the east, is 90. To the south is 180. To the west is 270. And if you come back to the north again, it's 360. Okay. Now, let's start. The question says, both cyclists left town C. And it says, cyclist A traveled for 5 kilometers on a bearing of 050 degrees, 050. And 050 is between 0 and 90. So, the line will come out from northeast. So this is my town C, and this is where cyclist A stopped, 5 kilometers, and the bearing is 050 degrees. It says cyclist B traveled for 15 kilometers on a bearing of 320. So from same C, 320 has passed 90, passed 180, passed 270, but it has not gone back to 360. So it's between 270 and 360. And that is northwest. So it will come out from there. And then this line, the second distance is 15 kilometers, which is bigger than the first one. So it's going to be longer. So if you look at these two lines, this is longer than this because this is 15 kilometers, while this one is 5 kilometers. So this is our B. Then at the end, you are expected to close the sketch to form a triangle. In bearing, anytime you make a sketch, you are expected to form a triangle. Now, the bearing, you have to put the arc 320 degrees. Good. So the sketch is ready. Let me remove all these ones so that it doesn't confuse you. Now, the sketch is complete. The second question says, calculate the distance between A and B, correct to the nearest whole number. If you look at the sketch, you discover that this is our A and B. This is missing. This side is missing. This side is 5. This one is 15. Why there is nothing here? And that's what we are calculating. In most cases, in bearing and distances, we use cosine rule to calculate missing sides or unknown distances. In this case, we are going to generate the cosine rule for this diagram. So the cosine rule is the square of the missing side. So AB squared, the square of the missing side, is equals to the sum of the squares of the other two sides, 5 squared plus 15 squared minus 2 times those two cos the angle facing the missing side, which is called an included angle. Now, this angle, we're supposed to get it from here. If you look at this point, we are talking about this angle. That is the angle facing the missing side. To get this angle, we already have a portion of it, which is 0, 5, 0. Then it remains this one. Once we get this, we add the two of them, and that will give us the angle we need. And to get it, if you look at this diagram, you will see that we have 320, which is from the north round up to this point. So to get this particular portion of the angle, what we need to do is 360, that is sum of the angles at a point, minus 320. And that will give us 40 degrees. So this portion is 40 degrees. And if you add the two of them, you will get 90 degrees. So the angle, our included angle is 90 degrees. And we'll put it here. That's what we are going to use in our calculation for the cosine rule. Now, when we move down, we have 25. 15 squared will give us 225. Then 2 times 5 will give us 10. 10 times 15 will give us 150 cos 90. Now, cos 90 is 0. So 50 times cos 90 is 0. Then when you add these two, it will give you 250 minus 0. So AB will now be equals to square root of 250. And that will give us 15.81 by 2 decimal places, which will, the question says, correct to the nearest whole number. So the nearest whole number of this is 16 kilometers. So that settles the second one. For the third one, it says, find the bearing of A from B, correct to the nearest degree. The bearing of A from B. So we're taking the bearing from B. It means we'll start from the north of B, draw our arc until it touches the line that goes to A. So the bearing is this arc here. If we find it, that is the bearing. So what do we do? In order to find it, we need to fashion out a plan which will help us get that. And the plan we can fashion out is this. If we can find this portion, that is this angle here, let me call it X, and then get this angle here. Let me call it y. Then we will now add two of them and subtract them from 180, because from this 0 to the south pole is 180 degrees. That is some of the angles on the straight line. If we get x, get y, we'll add two of them, subtract them from 180, we'll get the bearing. We'll get this arc we are looking for. Following that plan, x, let's get x. So to get x, x is alternate to this angle 40 here. So x is equals to 40. And the reason is alternate angles are equal. Then y, for us to get y, we need to employ sine rule. So say sine y over the side facing sine y, 5, equals to sine 90 over the side, which we got 15.81. We take the value before approximation. Good. The next thing is you cross multiply. If you cross multiply, you will get 15.81 sine y equals to 5 sine 90. Then let me continue here. So continuing here, I will have 15.81 sine y equals to 5, because sine 90 is 1. So 5 times 1 is 1. Then is 5. Then sine y equals to 5 over 15.81. And when you divide that, you will get 0.3163 y will now be equals to sine inverse or arc sine of 0.3163. That will give you 18.44 by 2 decimal places. That's what will give you. Of course, degrees. So that is our y. Now, we have found x, we have found y. We will need to add two of them and subtract it from 180. That will not give us the bearing. So the bearing of A from B is equals to 180 minus 40 plus 18.44. That will give you 180 minus, that will give you, if you do that, that will give you 121.56. When you do the calculation, that's what will give you. Then it says to the nearest degree. So the nearest degree of this number is 122 degrees. So that's bearing from of A, the bearing of A from B, which is this arc here. So in summary, anytime you are given a question in bearing and distances, it's always good you make your sketch. After the sketch, you can now proceed with the calculations. For distance, to calculate the distance, most times we use cosine rule. And during the calculation of bearing, sometimes we involve sine rule, to get the angle inside of the triangle before we can now conclude. I will show you another example which will help you to understand what I've just started. So stay tuned as we go to the next example. The second question says, a boy walks 7 kilometers from a point X to a point Y on a bearing of 0.65 degrees. He then walks to another point Z, a distance of 14 kilometers, on a bearing of 146 degrees. Illustrate this information in a diagram. Calculate correct to the nearest kilometer the distance from X to Z, and calculate the bearing of Y from Z. Now, to illustrate this information, the information is straightforward in the sense that there is an object moving, and that object moves from one point to another point. Anytime you have this type of situation in bearing and distances, it's always good to follow that object's movement from where it started and end where it ends. So in this case now, a boy is moving. So the boy started from point X. X will be our first point. We use the 4 cardinal points to represent X. And it says it moved to another point Y on a bearing of 0.65. Remember, 0.65 is between 0 and 90. So it will come out from northeast. So this is our Y. The angle is 0.65 degrees and 7 kilometers the distance. And it says from this point Y, it moved to another point Z, 14 kilometers and on a bearing of 146. So 146 has passed 90, but it has not reached 180. So it will come out from southeast. This line will be longer than the first one because it is 14 kilometers. And then finally, we close the sketch. This is our Z, and the angle is 146 degrees. Okay, so this is the sketch. The next thing is to calculate the distance X to Z. Of course, if you look at this situation, you discover that in this triangle, 2 sides are given and 1 is missing, and we're asked to find the missing one. And this missing side, the angle facing it is an included angle. So we need to find this angle here. We need to find this angle here, the angle facing that side. That will enable us to use cosine rule. So the included angle now has 2 parts, this one and this one. Let's call the first part X, A, small a, and call the second part small b. At the end, we add the 2 together to get our included angle. So to get A, we will say this 0.65 is the same thing as A. So A is equals to 0.65. And the reason is there are alternate angles, and alternate angles are always equal. So what of our B? If you look at B here, you discover that there is another angle outside of it, which is the 146. So from 146 to this place, remember, at X pole, the angle is, at South pole, the angle is 180. So if we have 146 already given, to get the remainder of that angle, we will now say 180, which is some of the angles on that straight line, minus 146. And if you do that, you will get 34 degrees. So our A is 65, our B is 34. And if you add both of them, so I will remove this and put 65 there. I will remove this and put 34 there. If you add both of them, that will give you 99 degrees. So our included angle is 99 degrees. We can now go ahead and use the cosine rule. Now, to generate the cosine rule for this shape on the board, xz squared equals to the sum of the squares of the other two sides. So 7 squared plus 14 squared minus 2 times 7 times 14 cos 99. If you continue, that will give you 49 plus 196 minus 196 cos 99. And if you continue, that will give you 245 plus 30.06. Now, plus 66, sorry. Minus 196 cos 99 will give you plus 30.66. If you use your calculator and do that. Then, if you continue, that will give you 275.66. Then xz is equals to square root of 275.66. And that will give you 16.60. And the question says, correct to the nearest kilometers. And if you correct to the nearest kilometer, it will give you 17 kilometers. So the bearing of y from z y from z. That means you go to z, starting from the North Pole, draw your arc until it touches the line going to y. So the angle we are looking for is this arc. How do we go about it? We can get this small portion here because it shows that the bearing, the angle is more than 270, but close to 360. It's not up to 360. And because of that, we can find this small portion here. That small portion is alternate to 34, is equals to 34, and there are alternate angles. So this small portion here, let me call it small a, small a. So this small a is equals to 34 degrees, and that is alternate angles. And then finally, the bearing is equals to 360 minus 34. 360 minus 34. And that will give us 326 degrees. So the bearing here is straightforward in the sense that once you get this A, which is 34 alternate angles, you subtract it from some of the angles at a point, which is 360 degrees. And once you do that, you get 326 degrees. So the bearing, let me write it out here, bearing of Y from Z is equals to 360 minus 34, and that will give you 326 degrees. So that is that. I'm going to show you another example that will also help you to understand it the more. The third example says the points A, B, and C are located such that B is 15 kilometers south of A, C is 20 kilometers from A on a bearing of 270 degrees. Calculate BC to the nearest degree, the bearing of B from C. Now, it's always advisable to make the sketch, that is, represent the information in a diagram. That will give you a clearer picture of what you're expected to do. Now, there are 3 points where we're going to start the drawing from. It says B is south of A, and then C is also from A. It means our diagram, the first point we're going to draw is A. So we take this to be our A. It says B is 15 kilometers south of A. So south means this is the south of A. Draw a straight line down. So that is your B. So A, B is south of A, 15 kilometers. So south of A means the same thing as due south. Say due south of A means a straight line from south of A. If it says due east of A, it means straight line from the east. If it's due north, it means straight line from the north. Then it says C is 20 kilometers from A on a bearing of 270. Now, if you go to A, 270 is exactly west. Remember, when starting, north is 0, east is 90, south is 180, west is 270. So if it's exactly 270, that means it is exactly west of A. Then this line will be longer because it's 20 kilometers. So that is our C, 20 kilometers. And then, of course, the angle is 270 degrees. You close it to form a triangle. The sketch is complete. It says find BC. Find this distance, BC. Of course, we're going to use cosine rule as well. Before we do that, let's get our included angle, the angle facing the missing side. This case is simple in the sense that since everything is 270, it passed 180, it ended at 270, meaning that to get only this portion, which is what we are looking for, is going to be 270 minus 180. That will give us 90 degrees. So here is 90 degrees. That's our included angle. Forming the cosine rule from this diagram, we'll have BC squared is equals to 15 squared plus 20 squared, the sum of the squares of the other two sides, minus 2 times 15 times 20 cos 90. 15 squared is 225 plus 400 minus 2 times 15 will give you 30 times 20, 600 cos 90. If you add these two, it will give you 625. Then minus 600 cos 90 will give you 0. Then BC will now be square root of 625, which will give you 25. Don't forget kilometers. So that is our BC, 25 kilometers. To calculate the bearing of B from C, this is B here, from C, means go to the north of C and take the bearing. Draw an arc until it touches the line going to B. This is the bearing. So how do we do that? If you check, from 0, we have passed 90 before coming down to this point, meaning that the angle up, the upper part of the angle, let me label them, X and Y. So our X is 90 degrees. We started from 0 to 90, so here is exactly 90. So that is, so we say X is 90 degrees, the right angle. Then Y, we need to use sine rule to find our Y. By the time we find Y, we now add the two together to give us our bearing. So I will now say sine C, which is sine Y, which is only this portion, over the side facing it, 15, is equals to sine 90 over 25. Remember, we have found 25 as the side facing this 90. You cross multiply, you have 25 sine Y equals to 15 sine 90. Then 25 sine Y equals to, sine 90 is 1. 15 times 1 is 15. So sine Y is equals to 15 over 25. That will give you 0.6. To give you 0.6. Then Y is now sine inverse of 0.6, which will give you 36.87 by 2 decimal places. So we have found our Y. So to find the bearing of B from C is equals to X plus Y, which is 90 plus 36.87. And that will give you 126.87 The question says correct to the nearest degree. So the nearest degree is 127 degrees. So far, we have seen that once you are given any question on bearing and distances, it is always good you make a sketch. You present the information in a diagram, whether you are instructed in the question or not. Like in this example, we are not instructed to illustrate. But it's always good you show the diagram. Even in some external exams like WAEC and NECO, you'll be given mark for showing this diagram. Once you finish the sketch, the next thing is the distance. Of course, you use the cosine rule, form cosine rule of the diagram you have drawn, get the included angle, that is the angle facing the missing side, do your calculation, get the missing side, and finally the bearing. When you make the arc, you now check how you are going to go about finding different parts that make up that angle we are looking for. So in this last one, we saw that we have x and y. We got x because it is a right angle. The arc started from 0 and reached east, which is 90. That's why we got x equals to 90 degrees. And then our y, we had to use sine rule to get the angle inside of the triangle. That gave us 36.87. Finally, we added the 2 to give us the bearing we are looking for. So far, we have seen that the 3 things we need to do anytime you are asked questions on bearing and distances is you make the sketch, then calculate the distance, and then the bearing that follows. Thank you very much for joining me in this lesson video on bearing and distances. Hope you enjoyed this class. I hope to see you very soon. There are other videos on other topics. You can check them out and get the knowledge required from them. Thanks for watching, and bye for now.